This is an MK14, at least that's what I'm going to call it, and it's an early computer from around about 1980, something like that, and it's a very simple 8-bit microprocessor computer. You can write programs on it, and this one comes with this VDU add-on here, so you can get video out, and I've got a monitor down here attached so we can see some video out. The basic display was this calculator display over here and this keypad, and these are dome switches, and the original had a set of keys, sort of plastic overlay that went on top of here, and the original owner of this actually took that overlay, cut it up and stuck it onto keys here on these quite nice sort of cherry type keys. I'm not sure what they are exactly, and unfortunately the glue has aged over the years, and it's been quite a few years, and some of these have fallen off. I've got a couple here that I kept, but I've actually stuck some handwritten ones on here. I might buy a modern keypad and cut it up and stick those on or something. I'm not sure what I'll do with that. In fact, I'm not sure what I'm going to do with the whole thing, to be honest. As you can see, I have done some things with it. That is not original, even though the IC clip probably is around about 1980, maybe a bit later. It's got a very small amount of RAM, just a few hundred bytes. It's got quite a lot of I/O though. There's I/O that drives the keyboard, and there's a chip here that provides various I/O lines that you can use to control other stuff. The VDU, so there is a card edge connector here, and I think there's some holes down there where all these wires are coming out, and you could attach it and make a very long sort of computer and put the VDU out the top, but that wasn't done here. This was done with wires which have been wired from the edge connector, electrical connections, underneath this MK14 board, and then wired directly to the bottom of the processor, which I think was an official way of attaching it. That was one of the ways that it was supposed to be attached. Quite a lot of wiring required, and I suspect this isn't massively reliable. It's been okay so far. What else have we got? We've got a power supply. We'll start on the input here, which does have exposed mains on it, but fortunately it's only this area here, so as long as I stay away from that I'll be fine. Big capacitor, hasn't let go yet. Then down here, bridge rectifier and a regulator. This bridge rectifier gets very hot. There's also another regulator here, which I think is for powering the VDU card. That gets, well, let's call it on the hot side of warm. In fact, it's hot now because there's a strange aspect to this machine, and that's that the 5 volts, even when it's off, the 5 volts is the only thing that's off. Everything else is on, which is a little bit strange. But anyway, power switch here, which just turns the 5 volts on. Keyboard attached through a ribbon cable. Ribbon cable here, which then goes into an edge connector here, and this is a dedicated edge connector for the keyboard. And then there's a load of switches here. These two don't do anything. I might wire those up actually later on. This is all to do with the video card here. You've got which addresses of memory you're going to get the video characters from. You're either going to get 2 copies of 0B00, or you're going to get from 0F00 and 0B00. So one half will be one and the other half will be the other. You've got graphics and characters here, so you've got text and graphics, and it's a sort of block-based character graphics setup. Inverse video, that doesn't work very well on this. It does convert to inverse video, but it's a bit finicky. and then top page, and that just determines whether your two pages are F00 0 at the top and B00 at the bottom, or B00 at the top and F00 at the bottom. The monitor's flickering here because it's powered up. I've done my own bodge. I've got a regulator and a barrel jack thing there. So this is going into a small reversing camera monitor, which gives quite a nice picture. It's quite low resolution, so it doesn't really matter. And that's about it. I'll turn it on. And you can see that there's a power on LED. That's original. I didn't put that on. Calculator displays come up, and it's running the monitor at the moment. So you can do a few things with memory. You could look at it, change it. Two things, okay, two things. And you can go, so you can go at an address. You can run a program somewhere. And you can see his characters have appeared here. If I flip that the other way around, you can see. I'll flip it the other way around there. You can see there's characters changing. I think that's the monitor program's RAM. We're actually looking at memory. And the way this VDU card works is that it sits there generating all the signals it needs to scan the video, and when it needs some data, like characters, to display, it goes out along one of these wires and stops the processor. There's a pin that stops the processor. Stops the processor, accesses the RAM at whatever address it needs, displays the video, and then releases the processor, and off it goes again. And it's a bit heavy-handed, but it works. It does take some time away from the processor that it could have been doing something, but there you go, you've got video. What I've got here is it's an RP20. I'll get that there. It's an RP23. It won't fit in the screen and the camera. It's an RP2350 board, which is just sitting on the processor bus, and it's emulating RAM. So this has now got more memory than just the. I think it's 1K. This has got, or is it half a K? I think it might be half a K. It's been expanded. It was 256 bytes, I think, originally, and then there's 2 extra chips, which takes it to half a K. But with the RP2350, you can have, you can fill all the gaps in. You could have whatever you wanted up to the limit of the RP2350, which I think is something around 500K. You could bank switch it if you wanted to and actually use that memory, but it would be a lot of typing entering that program. I've also got a USB monitor. There's a USB cable here. So I can do things while it's running, and one of the things I can do is actually load a program in. So one of the reasons I built this was to give it more RAM, and the other is to avoid typing. There's various programs I'd like to run, and I'd rather get them entered a little bit quicker than typing on this. And also, one strange thing with this computer is there's no cassette interface. There was an original cassette interface that you could get, and this machine doesn't have one, so I don't really know what it was used for and how the programs got in, or whether there were any, or it was just they spent a lot of time building it and got a VDU and then didn't reuse it much, or maybe the cassette interface has been lost and there was one. There's nothing underneath, at least I don't think there is. I've looked under there. There's no cassette interface. But anyway, one of the things I can do, which I will do, so I'm on the USB monitor input at the moment, is I can load a program like that. I just press one key, and that's now in the memory space of the MK14, and that's a lot quicker than typing it. And it actually lives at 0620, so here I can see that that says C4, and normally on this machine, if I haven't got this running, it'll come up with 3F, which is what you get with no memory at a particular address. And if I press go, you can see there's stuff going on. But this is designed to run in, flip it round, this is designed to run in graphics mode. So if I flip the graphics switch, you can see that you've got a Falling Man demo running. So at the moment he's falling out of, let's call it vegetation, at the top of the screen. And the reason for that, you've got men at the bottom and vegetation at the top, is that this switch here is set to display F00 at the top and B00 underneath. If I flip to 2 copies of B00, you get that, which makes sense. And if you flip back and you press the top page, he's now falling out of the sky and landing on, let's call them rocks, with some, well, I don't know, insects, we'll call them at the bottom, yeah. So this is the demo that I just loaded from the internal flash of the RP2350. There's no SD card on here. I thought it was a bit daft putting an SD card on there when you've got so little memory to play with. And this, it's an Olimex XXL card, and it's got 16 mega flash, which should be enough. You can probably put every program ever written for this into, well, probably 1/10 of that or less. So I've also got my little video mod here, which I'm going to tidy up. So I'm going to tidy up the stuff I've added, and I'm going to put a monitor on here so that you've got a monitor, you don't need to lug a TV round. This, I think I'm going to leave on the clip, because everything on this board is soldered in. Everything on the VDU board's in sockets, which is nice because I had to fix it. Where's the stuff I had to fix? It's here, so I had to fix that. These 3 ICs were faulty, so swap those out. And that's easy when you've got sockets, not so easy when it's soldered in. So the idea of the PCB that the Pico sits on is that it's got a pinout which is the same as the processor. So this is a 1-to-1 cable, and the idea was that you could stick the PCB in the socket of the processor, take the processor out, put it on the PCB, and then you've got the Raspberry Pi Pico stuff all on a sort of daughter board. But I don't think I registered that it was soldered in on the board when I started the board, so I laid it out, came back, and it was like, okay, I don't really want to take the processor out of this. So I don't know, I might mount that on another bit of wood up here or something on the monitor and continue the growth of this machine. But I think I will tidy some things up. There's quite a lot of wires going all over the place, and I mean, it seems quite reliable. The VDU connections here have been fine so far. But yeah, I need to put some inputs into the VDU card because it's got many pages it can run from. I think it's 6 bits, maybe 8, 6, something like that. And at the moment it's only running off these 2 pages, and quite a lot of the code that I've seen runs out of a page that I don't have mapped here. So I don't know whether I might use these switches here to do extra lines. I need to work out exactly which bits I need to toggle, or I might put a rotary switch on there, something like a hex rotary switch, so you can select the page, or I might get the Raspberry Pi to select the page, because there is mention of changing the page that you're displaying halfway through the raster scan and having different things displayed on the screen. But anyway, that's the MK14. I'm not really familiar with the machine code. It's not even assembly language on this. I'm not really familiar with the assembly language, so I might learn that and write some programs for that. And I might do some videos of that, because you can't see that display very easily here. And it's off at the moment while the VDU is running. Turn it off and back on, it will come up. It's quite readable actually, it's quite a nice display. But yeah, that is computing in 1982, I think was the latest date code I saw on the VDU. It was there was a lot more wiring involved.